Hi friends, welcome to all. In this video we are going to see the lab activity configuring HSRP. Here we can see our topology diagram, also our addressing table. We will go through the objectives of this lab activity. In part 1, build the network and verify connectivity. In part 2, configure first hop redundancy using HSRP. Also we will go through the background. Spanning tree provides a loop-free redundancy between switches within a LAN. However, it does not provide redundant default gateways for end-user devices within the network if one of the routers fails. First hop redundancy protocols, that is FHRPs, provide redundant default gateways for end devices with no end-user configuration necessary. So in this lab we will configure a CISCO's hot standby routing protocol, that is HSRP, a first hop redundancy protocol, FHRP. So this is what we are going to do in this lab activity. Here we can see required resources. So we need 3 routers, 1941, also 2960 2 switches, PCs, then Ethernet and serial cables. Now we will come to part 1, build the network and verify connectivity. In part 1 we will set up the network topology and configure basic settings such as the interface IP addresses, static routing, device access and passwords. Right. So step 1, cable the network as shown in the topology. Attach the devices as shown in the topology diagram and cable as necessary. So we are going to build this topology on the CISCO packet tracer. We need 3 routers, 1941, here is that, then 3 switches, 2960, then 2 PCs, we will rename all these devices. This is R2, here is R1, and this is R3. Also we have S1, this is S3, and we have PCA, also PCC, PC-C. Now we will connect these devices. Coming to connections, copper straight through from switch, fast Ethernet 0/6 to PCA, then fast Ethernet 0/18 to this PCC, and from G0/1 to this switch. Here we are going to use fast Ethernet 0/5. Here are G0/1 to fast Ethernet 0/5. Now we will select serial DCE. Here we can see serial ports are not available, so we will add these serial ports on these routers. First of all, we will add it on R1 and we will put off this device. So here is the switch, and here we can see this card, serial high-speed WAN interface card providing 2 serial ports. So we will use this, and now we will switch it on. Coming to R2 and coming to R3, we have to power it off. Right. Now we will select this serial DCE. Coming to R1, serial 0/0/0 to serial 0/0/0. From R2, serial 0/0/1 to R3, serial 0/0/1. Now we will connect these 2 switches, S1 and S3, using copper crossover from fast Ethernet 0/3 to fast Ethernet 0/3. Right, and we will label all these. Here we have serial 0/0/0, Also here serial 0/0/0, and here we have serial 0/0/1, and here also serial 0/0/1, and this side is DCE, and here also DCE. Here we used G0/1. Here also we used G0/1, and here is F0/5. Here also F0/5, and to this PC on switch F0/6, and on S3 F0/18. Now we will come to step 2, configure PC host. So we will get the IP address of these PCs. Here we can see PCA IP address is 192.168.1.31. We will copy this address. Also we can see the subnet to mask and default gateway. It's 1.1. So coming to PCA desktop IP configuration, here is the IP address, subnet to mask, and here the default gateway is 1.1. Now we will get the IP address of PCC. Here we can see that 192.168.1.33. Here we can see the subnet to mask and the default gateway. Coming to PCC, and here is the default gateway, it's 1.3. Coming to step 3, initialize and reload the routers and switches as necessary. So step 4, configure basic settings for each router. So we are going to configure each router. We have to configure all these basic settings. Here we can see disable DNS lookup, configure the device name as shown in the topology, configure IP addresses for the routers as listed in the addressing table, set clock rate to 128.0.0.0 for all DCE serial interfaces, assign class as the encrypted privileged exec mode password, assign CISCO for the console and VTY passwords, and enable login. Configure logging synchronous to prevent console messages from interrupting command entry. Then copy the running configuration to the startup configuration. So we will do these basic settings on these routers first. First of all, we will do it on R1. CLI. Continue with the configuration dialog. No. Enable configure terminal. First of all, we will disable DNS lookup. No IP domain lookup. Also we will set the host name as R1, and we will set the IP address for the routers. We have to go to the addressing table. Here we can see device R1 interface G0/1, and here we can see the IP address. Also we can see the subnet to mask. We will go to that interface gigabit Ethernet 0/1, and we will set the IP address as specified in the addressing table. Here is that, and the subnet to mask 255.255.255.0. no shut command. Also we can see the interface serial 0/0/0. Here we can see the IP address. We'll copy this address. Also we can see the subnet to mask. We'll exit and we will go to that interface. So serial 0/0/0, IP address 192. Oops, you already copied. We will paste it here, and we will give the subnet to mask 255.255.255.0. Also we will set the clock rate as specified, that is 128.0.0.0, and no shut command. Interface serial 0/0/0 changed state to down because the other end also we have to configure. Now we will enable secret class. Also we will go to line console 0 and we will set the password as Cisco. Login, also logging synchronous, and we will go to line VTY 0 to 15, password as Cisco. Login. Now we will save the configurations, copy running config, startup config. Now we will verify the configurations we have done on R1. Show running config, hostname enable secret, and here we can see IP address details of each interface, right? Serial 0/0/0. Here we can see that, oh, here we made a mistake. Here we can see the subnet to mask we configured incorrectly. So we will reconfigure this serial 0/0/0. Configure terminal interface serial 0/0/0. IP address 192. No, it's not 192. Here we can see that. And the subnet to mask 255.255.255.252. Copy running config, startup config, and now we will verify. Serial 0/0/0. Here we can see now it's correct, right? Now we will do it on the router R2. Device must be powered on, right? Here is the button, CLI. Continue with the configuration dialog. Now enable configure terminal. No IP domain lookup. Also we will set the host name as R2, and here we can see R2 interfaces serial 0/0/0. Here we can see the IP address, also the subnet to mask, interface serial 0/0/0, IP address, also subnet to mask 255.255.255.252. no shut command. Also we can see serial 0/0/1. It's a DCE. Here we can see the IP address. We will copy this address. Also we can see the subnet to mask. Coming to that interface, serial 0/0/1, IP address, here is that, and the subnet to mask 255.255.255.252. Also we will set the clock rate here 128000. no shut command. Here we can see the next interface on R2 is a loopback 1. Here we can see the IP address. We will copy this address. Also we can see the subnet to mask here. We'll exit interface loopback 1. We'll set the IP address. Here is the IP address, and the subnet to mask 255.255.255.224. Now we will enable secret as class, and we will go to line console 0, set the password as Cisco. Login, also logging synchronous. We'll go to line VTY 0 to 15, password as Cisco. Login, we will copy running config, startup config. We will verify the configuration on R2. Show running config. Here we can see interfaces serial 0/0/0. Here we can see the IP address and subnet to mask. Serial 0/0/1. Also here we can see the interface loopback 1 and its IP address. Now we will do it on R3. Now enable configure terminal. No IP domain lookup. Also the host name as R3. Now we will see the interface IP address. Here we can see the device R3. Interface G0/1 IP address is 192.168.1.3. Also we can see the subnet to mask. So coming to that interface, gigabit Ethernet 0/1 IP address, here is that, and the subnet to mask 255.255.255.0. no shut command. Also we can see the interface serial 0/0/1. Here we can see the IP address, also the subnet to mask. Exit interface serial 0/0/1 IP address and the subnet to mask 255.255.255.252. no shut. Next we will enable secret as class. Also we will go to line console 0 and we will set the password as CISCO. Login, also we will give logging synchronous. Now we will go to line VTY 0 to 15. Password as CISCO. Login. Copy running config, startup config. We will verify the configuration by giving the command show running config. Here we can see the IP address, details of gigabit Ethernet 0/1. Also the interface serial 0/0/1. It's correct. Now we will come to step 5. Configure basic settings for each switch. So disable DNS lookup, configure the device name as shown in the topology, assign class as the encrypted privileged exit mode password, configure IP addresses for the switches as listed in the addressing table, then configure the default gateway on each switch, assign CISCO for the console and VTY password, and to enable login. Then configure logging synchronous to prevent console messages from interrupting command entry. And finally copy the running configuration to the startup configuration. So we will do these basic settings on these switches S1 and S3. First of all we will do it on the switch S1. CLI enable configure terminal, no IP domain lookup, host name as S1, enable secret class, line console 0, password as CISCO, login, also logging synchronous, line VTY 0 to 15, password as CISCO, login. Now we'll go to our addressing table, and here we can see the device S1 interface is VLAN 1. Here we can see the IP address. We will copy this address. Also we can see the subnet to mask and the default gateway. We will set that. We have to go to that interface VLAN 1 IP address. Here is that. Then the subnet to mask 255.255.255.0. no shut. And also we will set the IP default gateway. It's 1.1. Copy running config, startup config. Now we will do it on S3. Enable configure terminal, hostname as S3, no IP domain lookup. We have to enable a secret as class, line console 0, password as CISCO, login also logging synchronous, line VTY 0 to 15, password as CISCO, login, and we have to check the IP address of S3 VLAN 1. Here we can see that. We will copy this address, subnet to mask and the default gateway. Go to the interface VLAN 1 and the IP address, here is that, and the subnet to mask 255.255.255.0, no shut. Also we will set the IP default gateway, it's a 1.3. We will verify show running config. Right, everything correct. So we will copy running config, startup config. Now we will come to step 6. Verify connectivity between PCA and PCC. Ping from PCA to PCC. Where the ping results successful, we will check that. We will get the IP address of PCC. Here is that. We will copy this address and coming to PCA desktop, command prompt, ping to PCC. Here is the IP address, and here we can see we are getting the replay. If the pings are not successful, troubleshoot the basic device configurations before continuing. Anyway, here it is successful. It may be necessary to disable the PC firewall to successfully ping between PCs. Right. Coming to step 7, configure routing. Configure RIP version 2 on all routers. Add all the networks except 209.165.200.224/27 into the RIP process. First of all, we will do it on the router R1. CISCO enable password as class, configure terminal, router RIP. Then we have a version 2, no auto summary, do show IP route connected. Here we are going to give the network 10.0.0.0, also the network 192.168.1.0. Copy running config, startup config. Now we will do it on R2. Password CISCO, enable password class, configure terminal, router RIP version 2, no auto summary. We will see the directly connected networks here. Do show IP route connected, and here we can see those networks. So we are not going to add this network 10.0.0.0. Copy running config, startup config. Now we will do it on R3. Password CISCO, enable password class, configure terminal, router RIP version 2, no auto summary. do show IP route connected, network 10.0.0.0, also the network 192.168.1.0. Copy running config, startup config. Coming to B, configure a default route on R2 using loopback1 as the exit interface to this network. Right, so coming to R2, CLI, configure terminal, IP route 0.0.0.0 space 0.0.0.0 space, we have loopback 1. Right, copy running config, startup config. Coming to C, on R2 use the following commands to redistribute the default route into the RIP process. So we have to go to router RIP, then we have to give this command default information originate. Coming to R2, configure terminal, router RIP, default information originate. Copy running config, startup config. Now we will come to step 8, verify connectivity. From PCA you should be able to ping every interface on R1, R2, R3 and PCC. Were all pings successful? We will check that. We will take our addressing table so that it will be more easy to ping. Right. So coming to PCA command prompt, first of all we will get the IP address of device R1 interface G0/1. Here is that. Ping to this interface. Here we can see we are getting the replay. Now we will get the IP address of serial 0/0/0. Ping to this interface. We are getting the replay. Now we will get the IP address of this interface serial 0/0/0 on R2. Here is that. Ping to, right, we are getting the replay. Now we will get the IP address of serial 0/0/1. Here is that. We are getting the replay. Now we will try to ping to this loopback 1. Here we can see we are getting the replay. Now coming to R3 G0/1. We are getting the replay. Coming to serial 0/0/1. We are getting the replay. Also we will ping to PCC. Ping to PCC. We are getting the replay. If the pings are not successful, troubleshoot the basic device configurations before continuing. Anyway, here it's a successful. Now coming to B, from PCC you should be able to ping every interface on R1, R2, R3 and PCA. Were all pings successful? We will check that now. If the pings are not successful, troubleshoot the basic device configurations before continuing. Right, so we will test that now. Coming to PCC, command prompt. Here is the IP address. Ping to this interface We are getting the replay. Ping to this interface. We are getting the replay. Coming to R2. Ping to this interface. We are getting the replay. Next interface. We are getting the replay. Coming to loopback. We are getting the replay. Now coming to R3. Ping to this interface. We are getting the replay. Coming to the next interface on R3. We are getting the replay. Now we will try to this PCA. Here is the IP address. We are getting the replay. Coming to part 2, configure first hop redundancy using HSRP. Even though the topology has been designed with some redundancy, 2 routers and 2 switches on the same LAN network, both PCA and PCC are configured with only one gateway address. PCA is using R1 and PCC is using R3. If either of these routers or the interfaces on the routers went down, the PC could lose its connection to the internet. So in part 2, we will test how the network behaves both before and after configuring HSRP. To do this, you will determine the path that packets take to the loopback address on R2. Coming to step 1, determine the path for the internet traffic for PCA and PCC. From a command prompt on PCA, issue a traceset command to the 209.165.200.225 loopback address of R2. Right, so here we are going to give this command. Coming to PCA, command prompt, and here we are going to give that command. And here we can see the output. What path did the packets take from PCA to this network? So coming to our output, here we can see it goes to this interface, that is the IP address of this interface, G0/1 on R1. Then it goes to that IP address what we given for traceset. That means the loopback 1 interface on R2. Coming to B, from a command prompt on PCC, issue a traceset command to this network loopback address of R2. Now, what path did the packets take from PCC to this network? Right, so we will check that. Coming to PCC, command prompt, and here we are going to give that command traceset. And here we can see it goes through 192.168.1.3. So this is the gateway of this PCC. That is the IP address of this interface, G0/1 on this R3. And then it goes to that IP address, the IP address of a loopback 1 on R2. Now we will come to step 2. Start a ping session on PCA and break the connection between S1 and R1. From a command prompt on PCA, issue a ping-t command to 209.165.200.225 address on R2. Make sure you leave the command prompt window open. The pings continue until you press Ctrl+C or until you close the command prompt window. Here we can see that command. So we are going to give this command on PCA. Here is that command. Here we have to give a hyphen, and here we can see. Coming to B, as the ping continues, disconnect the Ethernet cable from fast Ethernet 0/5. Here we can see that fast Ethernet 0/5 on S1. You can also shut down the S1 fast Ethernet 0/5 interface, which creates the same result. So what happened to the ping traffic? So we will check that. We will shut down this interface. We have to go to that interface fast Ethernet 0/5, and here we are going to give shutdown, and then we can see the result. It's down, and here we can see the result. Here we can see now it's request timed out. Coming to C, would be the results if you repeat step 2A and 2B on PCC and S3. Obviously we will get the same result. We will check that. Coming to PCC command prompt, here also we are going to ping to this address -T, and now we are going to shut down this interface fast Ethernet 0/5 on S3. CISCO enable class configure terminal. We will go to that interface fast Ethernet 0/5, and we will give shutdown command, and here we can see it's now request timed out. Right. Coming to D, reconnect the Ethernet cables to fast Ethernet 0/5 or enable the F0/5 interface on both S1 and S3 respectively. Reissue pings to this network 209.165.200.225 from both PCA and PCC to make sure connectivity is re-established. Right. So here we can see now we are getting request timed out. Coming to S1, enable password as class, configure terminal. We'll go to the interface fast Ethernet 0/5, and we will give no shut command, and here we can see now this interface is up. Here is that, and here we can see now we are getting the replay to this loopback 1. Coming to PCC, here we can see the ping to the interface loopback 1 is now request timed out. We are going to bring this interface up. Configure terminal interface fast Ethernet 0/5, no shut, and here we can see now this interface is up. Here we can see we are getting the replay now. Right. Coming to step 3, configure HSRP on R1 and R3. In this step, we will configure HSRP and change the default gateway address on PCA, PCC, S1 and S2 to the virtual IP address for HSRP. R1 becomes the active router via configuration of the HSRP priority command. Here we can see configure HSRP on R1. We have to go to the interface G0/1, standby version 2, standby 1. Here we can see the IP address what we are going to give. Then standby 1 priority 150, standby 1 preempt. Right, so we are going to give this command on the router R1. Coming to the router R1, password CISCO, enable password as class, configure terminal. We will go to the interface gigabit Ethernet 0/1, standby version 2, standby 1, then we are going to set the IP address, virtual IP address 192.168.1.254. Standby 1, then we are going to set the priority 150. Standby 1 preempt. Copy running config, startup config. Coming to B, configure HSRP on R3. Here we can see the command what we have to give on R3. Coming to the router R3, password CISCO, class, configure terminal, interface gigabit Ethernet 0/1, standby version 2, standby 1, IP 192.168.1.254. Coming to C, verify HSRP by issuing the show standby command on R1 and R3. Here they given the output for this show command. Here we can see that the show standby on R1. Here we can see this state is active. Here we can see the virtual IP address. Also we can see active virtual MAC address. And here we can see the priority what we configured, that is 150. And coming to R3, here we can see the show standby output. State is a standby. Here we can see the virtual IP address. Also we can see virtual MAC address. And here we can see priority 100. So this is a default priority. Also here we have some questions. Using the output shown above, answer the following questions. Which router is the active router? So here we have seen R1 is the active router. What is the MAC address for the virtual IP address? Here we can see that active virtual MAC address. Here it is. So same thing we can see on R3 also. What is the IP address and priority of the standby router? So here a standby router is R3. Here we can see that. We can see the virtual IP address 192.168.1.254. Also here we can see the priority 100. This is the default priority. Same show command we will verify on our routers R1 and R3. Coming to R1, here we are going to give a show standby, and here we can see the output. State is active. Here we can see virtual IP address. Also we can see active virtual MAC address. And here we can see priority what we configured. Coming to R3, show standby, and here we can see the output. State is a standby. Here we can see the virtual IP address and active virtual MAC address, and here is the priority 100. Coming to D, use the show standby brief command on R1 and R3 to view an HSRP status summary. Sample output is shown below. Here we can see that on R1 show standby brief. So P indicates configured to preempt. Here we can see the details. Also we can see on R3, here is the output. So same thing we will verify on our router R1 and R3. Enable show standby brief, and here we can see the details. Interface, group, priority, state is active. Here we can see standby, and here is the virtual IP address. Coming to R3, Cisco enable class show standby brief, and here we can see the details. State is a standby. Here we can see the virtual IP. Coming to E, change the default gateway address for PCA, PCC, S1 and S3. Which address should use? We will use this virtual IP address, that is 192.168.1.254. Right, so coming to PCA IP configuration, here we are going to give 1.254. Coming to PCC IP configuration, here is the default gateway. And coming to the switches, S1, password Cisco, enable password class, configure terminal, IP default gateway, here is that. Show running config, and we will verify that. Default gateway, copy running config, startup config, and coming to S3, password Cisco, enable class, configure terminal, IP default gateway, here is the IP address, this is the virtual IP address. Show running config, and here we can see that. Copy running config, startup config. Coming to F, verify the new settings, issue a ping from both PCA and PCC to the loopback address of R2. Are the pings successful? We will check that. We will get the IP address of loopback 1, here is that. Coming to PCA command prompt, here we are going to ping to loopback, here we can see we are getting the replay. Now we will try from PCC. Ping to the loopback, here is the IP address, we are getting the replay. Coming to step 4, start a ping session on PCA and to break the connection between the switch that is connected to the active HSRP router R1. Coming to A, from a command prompt on PCA, issue a ping-t command to this network address on R2. Ensure that you leave the command prompt window open. Right, so we will give this command. Coming to PCA command prompt, here is that command. Right. Coming to B, as the ping continues, disconnect the Ethernet cable from fast Ethernet 0/5 on S1 or shut down the F0/5 interface. What happened to the ping traffic? Right, we will check that. Here is our ping. Coming to the switch S1, configure terminal, we will go to the interface fast Ethernet 0/5. It's correct. Here we are going to give the command shutdown. Request timed out. Here we can see we are getting the replay. Coming to step 5, verify HSRP settings on R1 and R3. Issue the show standby brief command on R1 and R3. Which router is the active router? So we will verify that. First of all, we will verify on R1. Here we are going to give a show standby brief, and here we can see the details. But here we can see still the state shows active. Here we can see standby, it's 1.3. Also we will check it on R3. Cisco class show standby brief. Here we can see here state is active. So actually this router R3 is active now. What we are going to do, we are going to remove this connection from here, right? And we will try now. Once more we will give this command on R3. Here we can see now state is active. Also we can see the virtual IP address, and we will see now on R1. We will give this command again, and here we can see the state, it's init active unknown, standby unknown. Next is reconnect the cable between the switch and the router or enable interface faster Ethernet 0/5. Now which router is the active router? Explain. Right, so we will connect this R1 and S1 G0/1 to faster Ethernet 0/5. Also we will bring this link up, no shut. Here we can see that. Now we will see who is the active router here. Coming to R1. Again here we are going to give the show command, show standby brief. And here we can see that. Now state is active. Active is local, and here we can see the standby. Also virtual IP address. Now R1 is the active router. Coming to R3, show standby brief, and here we can see the state. Now it's in standby, and here we can see the active router, that is 192.168.1.1, that is R1. Right. Coming to step 6, change HSRP priorities. Change the HSRP priority to 200 on R3, which is the active router. So we will change the HSRP priority on this R3. Coming to the router R3, configure terminal, we will go to the interface gigabit Ethernet 0/1, and here we are going to give standby 1 priority specified 200. Copy running config, startup config. Now we will verify the active router. Cisco enable class, show standby brief. Here we can see state active, active local. Coming to R3, show standby brief, and here we can see still here the state is standby. So here the active router is R1. Next is issue the command to change the active router to R3 without changing the priority. What command did you use? So here we are going to use the command standby 1 preempt on this router R3 to change the active router to this router. Coming to R3, configure terminal, we'll go to the interface gigabit Ethernet 0/1, and here we are going to give standby 1 preempt. Here we can see gigabit Ethernet 0/1 state standby to active. Coming to C, use a show command to verify that R3 is the active router. right? So first of all we will check it on R1. Here we can see now this R1 in standby. Here itself we can see that message. Anyway, we will verify with the help of a show standby brief, and here we can see that state is a standby, and here we can see the active router, that is 1.3, that is this router R3. Coming to R3, here we will give show standby brief, and here we can see state is active, and here we can see the standby router, that is 192.168.1.1, that is the router R1. Hence here we can see the active router now is R3. Here we have a reflection question. Why would there be a need for redundancy in a LAN? Obviously with a single word we can give the answer, it's for the availability. Well, that's all in this lab activity, that is configuring HSRP. Friends, if you have any doubt in this lab activity, please comment below. Also, if you like my video, give a thumb and share to your friends. And finally, if you like to get my future uploading video info directly into your Gmail, you can subscribe this channel. Thank you.